Hello everyone, good morning. Uh, this presentation will be given by Yongqin Liu, who works in Android engineering team. So this is mainly on improving Android battery life. But in this exercise, we are really not looking into optimizing kernel or optimizing some kind of like going after the actual hardware and trying to play with the hardware to optimize it. But in this case, what we are trying to look at is the typical use cases that are like with tablet or with phone, Android phone and Android devices, the typical use cases that a user uses, like playing video continuously for many hours, playing audio continuously for many hours, or browsing, or so these are some of the use cases which we thought are common when a mobile or a tablet is being used. So we are trying to explore these use cases and trying to come up with possible areas of improvement, improving the battery life. So how could we run a particular use case for a long time on a given device? So that's the approach that we have taken. So it is a bit different from what you might have heard in the kernel or what you might have actually heard in the Android core area of optimizations. Like we are not dealing with the wake logs or some things like that. So just wanted to set this, like just wanted to give an introduction of what we are looking into. And this is again still a work in progress. We are supposed to complete this by end of April. So we thought it is best exercise for us to really present here. And if you guys have any inputs or if you guys have any more ideas to share with us, we will be really looking forward to it. So I'll let Yongqin start on this and take it forward. Thank you.
Okay. Hello everyone. Thanks for coming here. I'm Yongqin, working on the Linaro Android team now. I will talk something about my investigation on how to improve the Android battery life. About battery life, it can be improved by reducing power consumption. There are many methods. We can do the optimize from hardware, from software, and even we can extend the battery life as the user of Android device. From hardware, we can improve the product design, like using higher capacity battery or use less power consuming screens. From software, we can do the optimization on kernel driver layers or on the Android framework layers. We can also do the optimization from application layers. As the user of Android device, we can turn off Wi-Fi, Bluetooth, or GPS, or turn down brightness to extend the battery life. But here, we, as the Android software engineer, we will focus on the optimization of framework layer. We will try to make use of various kernel features from user space and try to provide optimized power management mechanism or interface for the application developers. Okay, let's first know something about the battery. Since the battery is the only source for Android device, so to extend the battery life of device, we'd better to know some basic things about it and know how it connects with the device. Now, nowadays, the main type used by Android device is the Li-ion type. And with the smart battery pack, we can get some detailed battery information, like the battery capacity level or current or voltage. Among the information, battery information, the capacity is the major factor that affects battery life. We can calculate the battery life like this. Divide the battery capacity with the current it generates. So from this formula, we can see that to expand the battery life, we need to control the total current generated by the battery, and it means that we can turn off some hardware models or make the hardware model itself to use less current. Here are some hardware models that impact the battery significantly. I list them here, and let's see how it depends how the power consumption will done by consumed, how the power will consumed by them. First device is the screen. The power consumption of screen is strongly influenced by the brightness. The higher brightness, the more energy it will consume. And to reduce the consumption, we need to lower down the brightness or turn it off. The second device here is the CPU. The CPU power consumption mainly depends on the frequency and the utilization. The higher frequency it is, the more energy it will consume, and the more utilization of the CPU, the more battery it will consume. So to make the device consume longer, it's better to make less use, make our application use less of the CPU. For the Wi-Fi, we know that the more data we transmit via Wi-Fi, the more power energy will be consumed by it. So to reduce the power energy, it's better to transmit less data or not translate the data. About the GPS device, Android provides some options for location mode on power consumption when we're using the location service. We can, for the battery saving, it's better to use less location service, like syncing up the location data less times, or use the battery saving mode. The last device here is the Bluetooth. Android supports the Bluetooth low energy from 4.3. So please use that if possible for your product. After the introduction about the battery and hardware, let's see from the software level. Wake lock is the mechanism Android provides for controlling power consumption. By acquiring the wake lock, we can prevent the device from the band, which is the low power state. And when we acquire the wake lock, that device will consume more battery. So we'd better be careful to use these wake locks. There are two classes provided such wake locks, the power manager and the Wi-Fi manager. Here we will only focus on the power manager. Here are the wake locks provided by the power manager. From these wake logs, we can see that only the state of the CPU or the state of the screen are controlled by these wake logs. But the detail degrees of the utilization degrees of the device are not controlled, like the frequency of the CPU or the brightness of the screen is not controlled by them. And this is where we will check later on how the degree control will affect the power consumption when wake logs are acquired. According to the wake log mechanism provided by Android, we can categorize the power consumption into two types. First is the active power consumption, where there is wake logs acquired and some processing ongoing. This use case, like the video playback case, or audio playback, or graphics display use case. Second type is the static power consumption, where all wake logs are released and only limited or no processing is ongoing. The system is waiting for wake-up event. This state, like the sleep or standby state of the Android device. Next, we will see how we can minimize the power consumption for these two types. Before that, here I list the tools I used. First is this battery mix. I used it to check how long and how fast the battery is consumed. We can see that from the chart. I'll be very simple. Next tool is the power tutor. I use this tool to check how much battery is consumed by each component or by each application. The last are some scripts. I used them to collect information of the battery LCD or CPU periodically. Here are the charts that generated with the data collected. Okay, let's see the test cases. The first case is the video playback test case. We compared the power consumption on video playback between different video players and different Android builds. And at the last, we found that there are much difference between the stock player and the MS player. MS player consumes about two times the power consumption of the stock player. From here, we can see that the battery capacity consumed by stock player is about 10%, but consumed by the MS player is about 19%. After checked with the information we collected, we found that the battery current is very different. And it mainly caused by the brightness of the battery. The stock player use use the lowest brightness we set in the settings, but the MS player, what the MS player used is 127. After we set the brightness to 5 while playing video via the MS player, we got the current and power consumption reduced. The result is similar as the stock player. The battery capacity consumed this time is about 9%. The result is similar as the stock player now. The second case we tried is the audio playback. Here we adjust the governor policy and the CPU frequency while playing an MP3 audio file. Here, from this table, we can see that the lowest CPU frequency generates the lowest current value, and the highest frequency generates the highest, the most current. But the difference here is very little. It's only 5. But it still shows us that there is the possibility we can save power energy via adjusting the CPU frequency or governor policy while playing audio file. Here, just show the possibility of the room. We can do more optimization. The third case we tried is the graphics display. Here we checked the effects of governor policy on power consumption with the zero-X bench test. For the 3D test, power save policy saved about 29 mAh than the on-demand policy. Here, this is the power save policy, and this is we use the on-demand policy. But for the 2D test, power save policy generates less current. It only 192 compared to the on-demand 352. But it took a long time to finish the test because of the reduced performance. And this makes more power energy consumed at the last. This is the consumption by the power save policy, and this is the consumption by the on-demand policy. So we need to pay attention to the performance when we adjust the governor policy to reduce the power consumption. The last case, is about the standby case. For this case, the most power-saving method is to power down the device. But this method can only be used when we are expected not to use the device for some time. Also, Android provides some battery saving modes for us. Like for the Wi-Fi, there is the Wi-Fi optimization option in the advanced Wi-Fi page. We can check it to extend to save the battery power consumption, to save power energy. And for the GPS, there also Android also provides the battery saving option for the location mode. We can use that on the location mode page. Android also provides us the method for controlling activities and background processes. They can be controlled. We can set these options on the settings developer options window. Besides the the features provided by Android, there are also some applications that can help us to save the battery life. Like the Bluetooth power tool. With this tool, we can make the Bluetooth only be turned on when we use it. You can try this tool. Okay, here are the conclusions we get from the above test case. First, the LCD brightness strongly influences the battery life. The second is we can improve the battery life by adjusting the CPU frequency or governor policy. And with this method, we, like I said before, we need to consider the performance. These conclusions are simple, but they are also means that we have room, have space to do more optimization in these two directions, with these two methods. Here are some suggestions I collected during the investigation. They are experience from the community. Maybe some of them are suitable for your product. I listed them here. Just hope it can save you some time when you have the similar problems. Among them, the audio tuning and sensor batching are two features supported from KitKat 4.4. If you can please use these two features as possible for your product. Here are some next steps, are something that we want to do next. First is to develop an application that can collect information as the script and show the data in a timeline-based chart to help analyze the system power consumption. The second is to develop an intelligent policy that maybe will run in the background, or to adjust the CPU frequency or brightness or something other things from the system level, and run automatically. This is something like the governor policy for the CPU level, but this is from the entire Android system level. And we'll check if we can integrate this policy or method into the power management framework. And the third one is to check the imprint of the auto sleep compared to the earlier suspend. And this is described by John Stout before. With the auto sleep feature, we can make the MP3 decoder device suspended before the screen off, which is not possible with the early suspend mechanism. Okay, here are some references. Okay, thank you. Any questions?
Maybe somebody in this Linux community would know, but okay. Is the second one from there, is it feasible or something that has been explored in other areas, like developing like system level governor kind of thing?
So a lot of vendors have tried to do something like this. Sometimes it's kind of a hack, where they, it's usually some user space a daemon that looks at what the use case is and tries to match activity to a use case and then configure the system in a certain way. It's very, very difficult, and in fact, it's not an approach that I think is not a great long-term approach, because especially on an open system like Android, you have an app store, you can download apps, and these apps may do things that you haven't considered. They may combine certain things in ways you hadn't considered. So it's difficult to map activity onto a predefined use case ahead of time, because you don't know really what the apps are going to do. So it's possible for apps you control, like if you control the video player application that ships with the device, and you know that that's what's on screen, maybe you can do something for that case, but it's hard to generalize. So. One question I had was like for the GPU, kind of the 3D graphics use cases that you were testing. It looked like you were varying the CPU power, the CPU frequency quite a bit, but were you also testing with affecting the performance of the GPU directly, like making the GPU run at a faster rate or a slower rate, or tweaking that in any way?
Did you get the question?
Sorry.
Okay, so yeah, on the graphics tests, so it looked like you were using the CPU-free governors to adjust performance.
Yeah.
But sometimes that's not the thing that matters the most. Often you want to adjust the performance of the GPU. The GPU can run fast, it can run slow. You might try to idle it or gate clocks between every frame, every 16 milliseconds, or you may say after wait until 100 milliseconds of inactivity to gate. So I was curious if you actually tested any policy around the GPU power management as well during this test.
I don't do the any policy on the GPU part.
We didn't do any power policy.
No, only CPU.
Do you think we should do that as well in this exercise?
Well, I mean, that's your decision, but basically, if you have a CPU-bound task, then in that case it matters a lot what your CPU frequency is and adjusting that. But I mean, for let's say for video encode or decode, typically you have some hardware blocks, some accelerators, and so those may run at different rates. So adjusting those rates is really important to that use case. Sometimes less so than the CPU. The same for graphics. If there are certain games, for instance, especially like casual games, which the actual CPU processing that needs to be done is very, very low, but you do a ton of graphics. And so in that case, you may want to, focus less on adjusting the CPU performance and more focus on adjusting the GPU performance.
Yeah.
And that's true for a lot of different things in the system. It's not about the CPU. It's the whole SoC has a lot of little pieces that can support different levels of performance.
Yeah, but here the current is gathered from the battery information, and this is the current about for the entire system, including the GPU, I think.
Are you gathering battery information from what Android supplies, like the battery information manager? Like, is it like how are you determining current consumption?
That's from the this in this part, there are from this file system.
Yeah. So it's always important to do real power measurements as well, if you can, because you're using software to infer how much power software is consuming.
Yeah.
So you can have a feedback effect, or it may just not be very accurate,
Oh, yeah.
or maybe the granularity is kind of large and you miss things in between. So if possible, being able to actually hook it up to a battery simulator or even a bench power supply that gives you current measurement would also be useful.
The problem there is we don't have a right hardware with
Yes.
complete
That's very difficult, I understand.
Yeah. That was, any other questions? Okay, so thank you very much. We will keep you updated on this, and we, as I said, like this is still a work in progress. So we will be doing more investigations, and we will keep you updated. Thank you. Thanks for joining. Thanks.